So let's go back to the RAB object that we got by contracting the curvature tensor, and say we do the RCABC. So we know that we get, let's just repeat it. D gamma C AC XB minus D gamma C AB XC plus gamma E AC gamma C EB minus gamma E AB gamma C EC. And we're going to find these components, and then we'll evaluate them for our sphere, and see how they give us some sense of the curvature, information about curvature. So this becomes, so we have indices 0 and 1, so let's make it easy for ourselves. So we get 0, A, 0 in XB plus D gamma 1 A1 in DXB minus D gamma 0 AB in X0 minus D gamma 1 AB in X1 plus gamma E A0 gamma 0 EB. We have to sum on the E as well, plus gamma E A1 gamma 1 EB plus, it's actually a minus gamma E AB gamma 0 E0 minus gamma E AB gamma 1 E1, and we get D gamma 0 A0 XB plus D gamma 1 A1 XB minus D gamma 0 AB X0 for the one component, and now we can evaluate the rest of this. Zero B, 1 A1, gamma 1 1B, Okay, so those are the different terms, and let's evaluate R00. Right, so we want to show that some of these components are not 0 because the object is curved. So this is a sphere, and we know what the connection coefficients are. We'll write them down in a moment, but we already evaluated them. So here we have R00 is gamma 1, 0, 1. With respect to theta is X0 is theta. Minus gamma 1, 0, 0 in phi, or X1, plus gamma 1, 0, 1, gamma 1, 1, 0. These are the same object. Gamma 1, 0, 0, gamma 0, 1, 0, 0, 0, 1, 0, 1. So let's just write the rest out, and then we'll evaluate them given that we know what the connection coefficients are. So R11 is equal to d gamma 0, 1, 0. That's R11, and we have R10. And we could do R01 and show that it's the same as R10. RAB is symmetric. Okay, so now we have to evaluate these. So we have, okay, so let's take our connections that we already evaluated before. We know that we have minus sine theta, cosine theta for that one, and then we have gamma 110, which of course is equal to 101, is the cotangent of theta. So R10, which is also R01, we didn't write that down, but we could. We evaluate that. We have derivatives. If we want to go and look back to what we have here, right, we have derivatives of gamma 111, 110 with respect to phi, but 110 is a function of theta, so that's 0. This is 0 because gamma 111 is 0. And then when looking at these terms, we have, see, 0, 1, 1, 0, there's no 0, 1, 1 here, and then 1, 1, 0s. 1, 1, 0s are here. 1, 1, 0, we're doing minus 1, 1, 0. I do here. Oh, but we're multiplying this, sorry, this is a 0, 1, 0, so this is 0 as well. So we get 0 for all these terms. And let's do R00. R00 is, so in terms, if you look at the derivative, we have 101 derivative with respect to theta, so R00 has a d by d theta of the cotangent of theta. Then we have a gamma 101, 101 squared, right? So you can look at that again, of 101, and that gets squared, so we have a plus a cotangent of theta squared. And so, let's see, we get This is minus 1 minus cotangent squared of theta, right? Because we're taking the derivative of the cosine theta over the sine of theta. So we get that, and so we're adding this. We get plus cotangent squared of theta, and that's equal to minus 1. And R11, we have a derivative in theta of gamma 0, 1, 1. Gamma 0 minus that, so we have a gamma 0, 1, 1 is negative, so overall we'll get a d by d theta of the sine theta cosine theta. And then we have gamma 0, 1, 1 that survives. So we have a minus sine theta cosine theta, and that gets multiplied. So that's gamma 0, 1, 1 times gamma 1, 1, 0. So we have cotangent of theta there. Right. So this gives us a cosine squared theta minus sine squared theta. And then we have minus cosine squared theta, and that's equal to minus sine squared theta. So, I think the Ricci tensor is actually, because the Ricci tensor is has positive terms, so it's 1, 0, 0 sine squared of theta. I think it's actually r mu nu equals r, we're using Greek indices now, mu, it's the middle one that we contract. So it's not the one that we just use here. The one that we use here gives us minus that. So this object with these components gives us some information about the curvature. And there's another object that we'll look at, which is just a pure number, which we'll get from this. So we're doing the curvature tensor to the Ricci tensor to the Ricci scalar.